Let's have a think about waterfalls. Now, waterfalls are found where you've got different types of rock that lie side by side. And the way that rocks are laid down, particularly sedimentary rocks, they're laid down in layers. So you might get a harder rock, which is overlying a softer rock underneath. Now, if a river is flowing over the top of that, so here's the river, if it finds any weakness at all in that hard rock, it's going to manage to exploit it. Or it might just be that the hard rock naturally ends at that point. So anywhere where the hard rock ends, it's going to expose the soft rock underneath. And that soft rock is going to be eroded by the river very quickly. Now, as the river comes over this lip here, it's going to hit the surface at the bottom pretty harshly, and you're going to get a high degree of hydraulic action there. And what's going to happen is all that erosion there is going to wear away the river and turn it into a waterfall as we would know it. So the bottom here, you'd call this a plunge pool, where the water plunges down into it. So what we get now is a situation where the water is cascading over and splashing at the bottom. And the river then continues along its way. Now, this soft rock here is going to be really exposed and very, very vulnerable. So what's going to happen over time is that it's going to continue to be undercut and eroded. And that section there is going to get deeper and deeper. Now, when it gets to this point, you've got all this rock here, which is not really supported by anything. And you've got the water going over the top, which is going to be really heavy, because water is heavy. If you think about water in a bucket, that bucket would be heavy to pick up. If you think about a whole river flowing over the top, there's a lot of weight that's got to support. And if this undercuts too much, it's just not going to be able to do it. And that whole section there is going to break away. The waterfall is effectively moved. It's retreating upstream. And this whole process is going to carry on. So the next thing that's going to happen is this bit will be undercut. That bit will be exposed, it will collapse, the waterfall retreats further. So this process is going to carry on. The undercutting will continue, the waterfall will continue to retreat, and this hard rock that's fallen off the top will actually be in the bottom of that plunge pool there. And that will cause the process of abrasion, which is where the rocks in the bottom, as they're being moved around by the river, and the water that's falling will be scouring out the landscape underneath and scouring that plunge pool even deeper. So hydraulic action and abrasion, really important processes in the formation of a waterfall. Now, one thing we forgot to say is that waterfalls are generally only found in the upper course of a river. And if we remember that you get downwards erosion in the upper course of a river, that's vertical erosion, you can perhaps understand why. When this river is much higher than sea level, it's going to try to erode downwards, and that's why it will exploit any weakness that there might have been in that hard rock. If that river was in the lower course, already at sea level, well, it wouldn't really want to erode downwards because it's at sea level already. It would use all of its energy eroding sideways or laterally instead. So that's pretty much an overview of a waterfall. But alongside waterfalls, we also get gorges. So let's see if we can draw what a gorge would look like. Now I'm going to try and do a 3D drawing here. So if this is the river coming along, and it flows over the edge as the waterfall, and then it carries on. if we're assuming that that waterfall retreats upstream, it's probably going to be moving over time further and further back until, let's say, it gets to about here. Now when it gets to this point, it has already cut away all this section of land here. And now the waterfall appears to drop down into a chasm and come out a gap at the bottom. It's not eroded the sides because the river hasn't been flowing there. The river's just been flowing just this section here. So what it's created is this landform here. And we would call that landform a gorge. Let's recap waterfalls and gorges. Question 1. Which part of the river would you find a waterfall? The upper, the middle or the lower course? Waterfalls are found in the upper course of a river, and that's because they require vertical or downwards erosion. Question 2. In a waterfall, does hard rock lie above soft rock, or does soft rock lie above hard rock? In a waterfall, hard rock lies above soft rock. It's the soft rock underneath that's being protected by that hard rock, and then when there's a gap in the hard rock, it exploits it and it causes the waterfall. Question 3. Which two types of erosion are most common in the formation of waterfalls? Hydraulic action and abrasion are both common in the formation of waterfalls. Hydraulic action involves the sheer force of the water, which happens as the water cascades over the edge. And abrasion is caused by the material that is in the bottom of the waterfall that is broken off, which scours out a deep pool beneath. Question 4. What is the deep pool called at the bottom of a waterfall? The deep pool at the bottom of a waterfall is called a plunge pool. And question 5. What's this landform that's created as a waterfall retreats? Well, that landform there is a gorge, and it's created as the waterfall erodes a deep chasm in the land that it leaves behind. I think that's pretty much covered it for waterfalls.